What if we could activate one of the body's own signaling pathways to target the deep abdominal fat that is hardest to reach, and do it with a peptide already backed by randomized human trials? Tesamorelin may be one of the most fascinating peptides in modern metabolic medicine. It works upstream, prompting the body to release its own growth hormone and natural pulses. In the right clinical setting, the resulting changes in visceral fat have been measurable, meaningful, and remarkably selective. Today we are exploring what makes tesamorelin so exciting, its effect on visceral fat, its connection to growth hormone and IGF-1 signaling, the emerging questions around liver fat and body composition, and how an intelligent medical evaluation can separate a compelling candidate from the wrong tool for the wrong person. Let's dive in. Tesamorelin is a synthetic analog of growth hormone-releasing hormone, often shortened to GHRH. It signals the pituitary gland to release the body's own growth hormone impulses. Growth hormone then influences the liver and other tissues, including production of insulin-like growth factor 1, or IGF-1. That distinction matters. Tesamorelin is not injected growth hormone. It works with an intact hypothalamic pituitary system, preserving the body's pulsatile signaling. That is a major reason researchers became interested in its potential to influence body composition with greater physiological precision. The FDA-approved indication is precise: reducing excess abdominal fat in adults with HIV-associated lipodystrophy. Lipodystrophy can occur in people living with HIV, particularly in the context of earlier antiretroviral treatment patterns. It may involve abnormal fat distribution, including increased visceral adipose tissue, the metabolically active fat surrounding internal organs. Visceral fat is not the same as the softer subcutaneous fat beneath the skin. It is also not the same as total body weight. A therapy can reduce visceral fat without producing dramatic scale weight loss or cosmetic spot reduction. In 2 large phase 3 trials, more than 800 adults receiving antiretroviral therapy were studied. At 26 weeks, tesamorelin produced about a 15% placebo-adjusted reduction in visceral adipose tissue. Triglycerides and some cholesterol measures improved modestly, while abdominal subcutaneous fat changed very little. For people who continued treatment, the visceral fat reduction was maintained through 52 weeks. But when treatment stopped, visceral fat returned. That tells us the effect is treatment dependent, not a permanent metabolic reset. That selectivity is the headline. Tesamorelin was not simply making people lighter, it was influencing the location of fat, the deep visceral compartment associated with some of the most important metabolic consequences. A smaller randomized study of 50 adults with HIV and abdominal fat accumulation also found a modest reduction in liver fat over 6 months. This opens an intriguing research question. Could changing the growth hormone axis and visceral fat biology influence fat stored in the liver as well? The early signal is promising, although broader trials are still needed before extending that conclusion to routine fatty liver treatment. And this is where tesamorelin's future potential becomes especially interesting. Growth hormone and IGF-1 influence body composition, recovery, tissue maintenance, and metabolism. Those connections have naturally created interest in healthy aging, performance, physique, and metabolic optimization. The biology gives researchers legitimate reasons to ask these questions. What we do not yet have is the same depth of clinical proof for those broader goals that we have for visceral fat reduction and HIV-associated lipodystrophy. But let's follow the biology, because the possibility map is much bigger than fat loss. Start with muscle. In an exploratory analysis of the pivotal trials, people who responded with meaningful visceral fat loss also showed increases in the area and density of several trunk muscles. That does not yet prove greater strength or athletic performance, but it raises an exciting possibility. Better body composition may mean not only less harmful fat, but healthier lean tissue and less fat infiltrating the muscle. Then there is metabolic flexibility. Growth hormone encourages the body to mobilize stored fat, while visceral fat reduction may lessen some of the inflammatory and metabolic signals produced by deep abdominal adipose tissue. Hypothetically, that could support healthier triglycerides, liver metabolism, insulin signaling, and cardiovascular resilience. We already see favorable movement in some intermediate markers. The larger question is whether those changes eventually translate into better long-term outcomes. The growth hormone and IGF-1 axis also participates in protein synthesis, connective tissue turnover, bone remodeling, and tissue maintenance. That creates credible hypotheses around exercise recovery, preservation of lean mass, tendon and connective tissue health, bone support, skin quality, hair biology, and physical vitality. These outcomes have not all been demonstrated with tesamorelin, but they are biologically coherent reasons for continued research. And then there is sleep. One of the most intriguing connections of all, the largest natural growth hormone pulse commonly occurs soon after we enter deep, slow-wave sleep. GHRH is part of that nighttime neuroendocrine rhythm. In small human experiments, giving GHRH increased slow-wave sleep, as well as nighttime growth hormone release. That creates a fascinating bidirectional hypothesis. Better deep sleep may support healthier growth hormone signaling, and more physiological GHRH signaling may, in selected people, support deeper and more restorative sleep. If that happens, the downstream experience could include better recovery, steadier energy, improved exercise readiness, and clearer thinking. But this distinction is important. Tesamorelin itself has not been established as a treatment for insomnia, sleep apnea, or poor sleep quality. The sleep benefit is mechanistically plausible, not yet a guaranteed clinical outcome. Still, for a field interested in restoring youthful biological rhythms, rather than simply forcing a single hormone level upward, this is an exceptionally compelling research direction. Cognition may belong on that map as well, in a placebo-controlled trial of older adults. With and without mild cognitive impairment, 20 weeks of a GHRH analog produced favorable cognitive effects. A newer study in people with HIV did not show a significant between-group cognitive benefit, so the signal's not settled. Yet the pathway touches neuroplasticity, metabolism, inflammation, sleep, and IGF-1 signaling, all relevant to brain health. Taken together, the hypotheses extend into mood, motivation, immune regulation, tissue repair, resilience, and healthy aging. Could improving visceral fat biology and restoring more youthful GHRH pulses help preserve function over time? Could better sleep, muscle quality, metabolic health, and recovery compound into a longer health span? Possibly. Could that mean longer life? We do not know. But these are exactly the kinds of high-value questions that make tesamorelin far more interesting than a simple belly fat peptide. For clarity, FDA approval is specifically for reducing excess abdominal fat in adults with HIV-associated lipodystrophy. Broader uses remain off-label or investigational and require a careful, individualized discussion of evidence, goals, and uncertainty. Like every therapy that meaningfully changes a biological pathway, tesamorelin deserves appropriate screening and monitoring. Tesamorelin increases IGF-1, so clinicians monitor levels and reconsider treatment if the elevation becomes persistent and the benefit is not strong. It is contraindicated with active malignancy, pregnancy, disruption of the hypothalamic pituitary axis, or allergy to the product. A previous malignancy requires individualized risk assessment. Glucose status should be evaluated before treatment and monitored during therapy because glucose intolerance or diabetes can occur. People with diabetes may also need retinopathy monitoring. Other potential effects include fluid retention, joint discomfort, carpal tunnel symptoms, hypersensitivity, and injection site reactions. The goal is not fear, it is intelligent patient selection, appropriate monitoring, and a clear reason for treatment. There is also a product distinction that should never be blurred. Agrifta WR and Agrifta SV are different formulations with different labeled dosing instructions, and the FDA label states that they are not substitutable. If a patient-specific compounded medication is considered where legally permitted, it is not FDA approved, has not undergone FDA pre-market review for safety, effectiveness, or manufacturing quality, and should not be assumed equivalent to Agrifta WR or Agrifta SV. Compounding may still have a lawful, patient-specific role. Product identity, sterility, potency, storage, and the clinical rationale simply need to be evaluated with the same seriousness as the therapeutic goal. So how should an evidence-first patient think about tesamorelin? First, ask whether the goal actually matches the studied condition: excess visceral abdominal fat associated with HIV lipodystrophy. Second, ask how success will be measured, not only on the scale, but through the clinical markers that match the actual goal. Third, ask how IGF-1, glucose, adverse effects, malignancy history, and treatment response will be monitored. Fourth, ask exactly which product and formulation is being discussed, and whether every claim being made belongs to that product, route, and population. Here's the bottom line. Tesamorelin has a real mechanism, a real FDA-approved indication, and meaningful randomized human evidence for reducing visceral fat in adults with HIV-associated lipodystrophy. That makes it more evidence-based than many peptides promoted online. Its broader potential in sleep, metabolic health, body composition, muscle quality, liver fat, cognition, recovery, tissue maintenance, performance, and healthy aging is exactly why Tesamorelin deserves continued attention. Some of that promise is established, some is emerging, and some remains a compelling scientific question. The opportunity is to explore that frontier without confusing possibility with proof. Mind-body-spirit medicine can provide an individualized medical evaluation to determine whether an evidence-based, lawful treatment pathway is appropriate. This episode is education, not a personal recommendation. If you value physician-led peptide education that explores the potential without losing the science, subscribe above and share this episode with someone who is excited about the future of metabolic medicine. Then continue learning with the next episode in our Peptide Therapy series. Continue learning by selecting the next episode on screen, or explore the complete Peptide Therapy playlist. Subscribe for more physician-led education about the mechanisms, evidence, potential, and limitations of peptide medicine.